All right, question number 3. We're going to use the graph to identify the points, if any, on the interval AB closed, at which the function has an absolute maximum or absolute minimum. Okay, so since we're not going to have to write or solve out anything, I'm going to make this full screen and I'm going to blow this graph up a little bit. So we want the absolute highest and the absolute lowest point. The highest point occurs here at this hilltop. Looks like happens at point C2. The lowest point on this graph, now this is a local minimum, but the absolute lowest point occurs at this closed interval B, the end point. So we have the highest point, maximum at C2, lowest point at B. And so the function has an absolute maximum at x equals C2, absolute minimum at x equals B on this open interval. That looks good. All right. So the next one, question number 4, we want to determine from the graph whether the function has any absolute extreme values on the open interval AB. Does it have any extreme values? All right, so let's make this a little bit bigger. We do not have a highest point. These graphs curve out and they continue to increase, getting close to this open circle, but never really reaching it. So no maximum. We do have an absolute lowest value at C. So the lowest point is C, no maximum. So looking for the one that says absolute minimum. Function has an absolute minimum, x equals C, does not have absolute maximum value. A looks good. I think that's going to be what we're looking for. Okay, it's green. All right, we're going to go on to the next one. This is going to be number 5. We got 4 parts here. So we're going to use this graph to identify points on the interval AB at which we have local and absolute extreme values occur. So we're looking for local and absolute extreme values. All right, so let's blow this up. Let's talk about everything. So we have absolute lowest point is A. Absolute highest point is going to be S. Low and high. Now we do have local maximum. So when you get that hill, like this point is higher than all the points around it. So this is going to be a local maximum, Q. This could also be called a local maximum, even though this is the extreme maximum because you got that hill. It's an interior point. You also have a local minimum, okay, that valley point. This would not be a local minimum because it doesn't continue. You don't get that lowest valley point. Even though it's a low point, it's not an absolute lowest point. You got to have that valley. So we have 2 local maximums. Interior, going to be local. This is also the absolute maximum. This is the absolute minimum. Okay? So local minimum value. The local minimum occurs at R. What happened here? Local minimum. Does it only give me input symbols? Can I type R? This is a little bit strange. We should be able to type in R for local minimum. X equals R. Okay, not sure why I wasn't doing that a while ago. All right, so R is our local minimum. List the values where the local maxima occur. So local maximum, those mountain tops. So it's going to be at Q and S, interior points Q and S. Q, comma, S. All right, we're going to list the values where the absolute minima, absolute lowest point. It's going to be A. And then we're going to do the absolute maximum, the highest point that also occurs at S.